The typical survivor has a clothing judgment of 3.8 on a scale of 1 to 10, 10 being very picky. A group of 39 survivors went to a clothing store to get more clothes. When they returned, the judgmental score was 4.3, with an estimated population standard deviation of 4.9. First, it would be good to distinguish what the null hypothesis would be. Seeing new clothes will not change the way they feel about clothing. The alternate hypothesis would be going to a store will make survivors more picky about what they wear. The first step is finding what the T obtain is. To use that, this formula is needed. Using this equation, we can see that the mean is 4.3. We subtract the population mean of 3.8 from that. From there, we divide the estimated population standard deviation of 4.9 over the number of people in this experiment, and we square. From there, we get a T obtained value of 0.6365. Going to our T tables, we can find what the T crit would be. Seeing as we're not sure if they will become more picky or less picky, we would use a two-tailed test. So the T crit would equal 2.021. Here we can see that this does not fall within this region of rejection, so there will be no change in how picky the survivors are about their clothes. If the T obtained was greater than 2.021, then this would have been not rejected and proof that survivors will not become more or less picky. In a study, The Fear of Walkers Based on Their Attacks on Survivors, it can be said that the average survivor fear is 7.3 based on a scale of 1 to 10, 10 being very fearful. A group of 43 survivors were confronted with chained-up walkers. The average fear was 6.7, with an estimated population variance of 3.6. First, it is good to distinguish what the null hypothesis would be. The null hypothesis would be that even seeing a walker face-to-face does not affect how much a survivor will still fear them. The alternate hypothesis would be that when a survivor sees a walker face-to-face chained up, they will be less scared. From here, we'd like to find the T obtained. And to do so, we use this equation. The mean for this equation is 6.7, and subtracting the overall, or the population mean is 7.3. Since the estimated population variance isn't in standard deviation form, we square the 3.6, which will equal 1.8974. And divide that by the square root of n, which will be 6.5574. From here, we will get a T obtained of negative 2.0733. Seeing as we expect them to become less scared, we will use a one-tailed test. The T-crit will equal 1.684. Even though this is a negative number, it is still greater than the 1.684. So this is a significant equation. If this number was less than the 1.684, and it will not fall into the region of rejection and will not be significant. The last equation was a negative one-tailed test. This here is a positive. Survivors went on a supply trip to an abandoned market. On average, it takes them 2 days. 5 survivors with poor health went and took them 2.75 days, with an estimated population variance of 1.645. With this here, the null hypothesis would be that the survivor's health does not affect their ability to move. The alternate hypothesis would be that one in better health can obtain supplies faster than one in poor health. From here, we would use the T obtained equation. We would have our mean of 2.75 and subtract the population mean of 2. There we would divide that by the standard deviation, which becomes the 1.645 squared. So 1.1 divided by the square root 5. From here, we get a T obtained of 1.4357. This here is a one-tailed test because we assume that one in poor health will not be able to make the trip in 2 days. We go to our tables and see that the T-crit equals 2.015. Seeing as this number falls below, it is proof that one in poorer health will not be able to do the supply run as fast as someone in good health. If this number was above, it would prove that one in poorer health can do it just the same or even better than someone in good health.